Welcome to our channel. In this session, we are going to discuss about KNUTH MORRIS-PRATT algorithm, that is also called as KMP algorithm for pattern matching. What is mean by pattern matching? Given one text, one pattern, check whether the pattern is available in the text or not. That is called pattern matching. For pattern matching, in the last session, we discussed brute force approach. In this approach, assume the length of the text is n and the length of the pattern is m. What is the time complexity we achieved? We achieved a time complexity of big O of n into m. And this brute force approach also uses backtracking. Because of this backtracking only, the time complexity of pattern matching increases. Now coming to today's session, KMP algorithm. It generates a time complexity of big O of n. Now, to achieve this time complexity, what the KMP algorithm do? Simply consider an element of the text. You need to avoid comparison of an element of the text that have previously involved in comparison with the same element of the pattern. That means already comparison of the element of this text with the same element of the pattern, the comparison is done already. Now you need to avoid the comparison one more time. That means backtracking is not achieved. Backtracking is not achieved. Simply, how KMS algorithm works? Very easy algorithms. How it is works? Compare the first character of the text with the first character of the pattern. If both are equal, move to second one. If both are equal, move to next one. Whenever there is a failure, that means mismatch occurred, the KMP algorithm uses LPS table. Instead of using backtracking, whenever mismatch occurred, the KMP algorithm uses LPS table. This is also called as prefix table. So, a pre-processed table, LPS table, also called as prefix table, also called as failure function. You can call with any name. By using this one only, to skip the comparison with the characters. So obviously, what is the first step? Enter into the algorithm. The first step is construct the LPS table. Once the LPS table is constructed, based on the LPS table, apply the KMP algorithm. Okay. Now I will construct the LPS table, and based on this one I will give you an example also. Now algorithm failure function, you can use any name, not a problem. Failure function of P. What is P? P is the pattern. Remember, we are calculating LPS table not for the text. Calculate LPS table for the pattern only. Now, along with the pattern, use one array F. This is my table. What is the size of table? Size of the pattern. Suppose if pattern consists of some 6 characters, the size of LPS table is 6 characters. Initially, at 0th position, I placed a value 0. No problem. After completion of algorithm, I will give one example. You will understand clearly. Initially, at 0th position of the table, I filled a value 0. Now, I am taking two values. I is equal to 1, j is equal to 0. I equal to 1, j is equal to 0. Now repeat a loop until end of the pattern. Assume m is the length of the pattern. M is the length of the pattern while I less than m. While I less than m, we are repeating the loop. While I less than m, we are repeating the loop. Okay. Inside the loop, what we are doing? First to do the comparison. If P of I is equal to P of J, what is the meaning? The first position character in the pattern is compared with 0th position character. Suppose if both are equal, then fill the table. Already 0th position is completed. Fill the first position. Like first position means I is equal to 1 with the value of j plus 1. With the value of j plus 1. After completion, after filling, increment I value by 1 and increment j value by 1. Increment I value by 1 and j value by 1. Suppose if there is a mismatch, else if, we are coming to if else in the sense both are not equal. Now check one condition. If j value is greater than 0 or not. If j value is greater than 0 or not. If j is equal to j greater than 0 means update j value as f of j minus 1. You are not updating any I. J is updated to f of j minus 1. Else, if this is also fail, then we are making f of I is equal to 0. F of I is equal to 0 and I value becomes I plus 1. This is the process. This is the algorithm. Very simple algorithm. Once we move with one example, you will get the complete idea. Suppose consider a pattern. Assume this is my pattern. A, B, A, B, A, C, A. Assume this is my pattern. Indexes 0, 1, 2, 3, 4, 5, 6. For this pattern, you need to construct the LPS table, also called as failure function. You can use any name, not a problem. Now, if the size of LPS is also same. 0, 1, 2, 3, 4, 5, 6. Okay. Coming to the algorithm. So, first f of 0. At 0th position, fill the value of 0 and initially I is equal to 1. Suppose I points to this position, j is equal to 0. J points to this position. Enter into the loop while I less than m. Suppose 1 less than m value is 1, 2, 3, 4, 5, 6, 7. So the length of a string is 7. Now P of I is equal to P of J. B is equal to A. That is my logic. B is equal to A. Condition false. If the condition false, we are moving into else if. In the else if, what is the condition? J greater than 0. Right or wrong? No. J value 0. Else if is also false. Else. In the else, we are writing f of I is equal to 0. What is the value of I? 1. F of 1 is equal to 0 and I is equal to I plus 1. I is incremented. Again, repeat the loop. P of I is equal to P of J. A is equal to A. Condition true. Whenever the condition true, f of I, what is I value right now? 2. f of 2 is equal to j plus 1. J value is 0, 0 plus 1. At second position, insert a value 1. Increment the I value and j value. J is incremented, I is also incremented. Now repeat. B is equal to B. Yes, again the condition is true. F of 3 is equal to j plus 1. J value is 1. J plus 1 value is equal to 2. Again, increment I value and j value. J and then I. So, A is equal to A. Again, there is a match. So, f of 4 is equal to j plus 1, 2 plus 1, 3. Increment I value and then j value. I value and then j value. Now, C is equal to B. Condition false. Whenever the condition false, move to else if. Check j is greater than 0 or not. Yes, the j value is 3. Now what is your step? J is updated to f of j minus 1. J value is equal to 3. F of 3 minus 1, that is f of 2. What is f of 2 value? 1. Now j is updated with the value 1. J now points to this position. J points to this position. Now after that, again do the comparison. Here I am not updating any I value. Yes or no? Update only j. Now same, C is equal to B. C is equal to B. Mismatch occurred. Move here. J is greater than 0. Yes. Now again j is equal to f of j minus 1. 1 minus 1, 0. F of 0. Now j value becomes 0. Now again do the comparison. C equal to A. Again the condition fail. J greater than 0? No. That is also fail. Finally f of I value is equal to 0. I is equal to 5. F of I value 0. I is incremented by 1. In the next step, A is equal to A. Yes, matching. F of 6 is equal to j plus 1. That is 1. I is incremented by 1 and j is incremented by 1. Yes. In the next iteration, this condition failed. So, I value becomes 7. 7 less than 7, condition fail. We comes out, the LPS table is constructed. Even though you are not knowing the algorithm, it is very easy. So, very easy. First time A appear 0 times. B. Before B appear? No. Now A. Already A appear here 1. B. Continuation to A. Understand the point? B is continuation to A. That is second. Now A is continuation. A, B, A. Here also A, B, A. So see, not appear before and A again appear. I think you got me. So if the pattern is repeated, according to the repetition, we are increasing the value. So by using this function, we are constructing the LPS table. We have another way also. By using the concept of proper prefix and proper suffix, you can do anyway. Anyway, in the next video, we will move to that way. That is LPS table construction without using this function. A simplified way of constructing LPS table. We will discuss that thing also in the next session. Now, LPS table is constructed successfully. What is the next step? Obviously, the next step is KMP algorithm. KMP algorithm. Write down the KMP algorithm of, suppose text 0 to n minus 1, comma pattern 0 to m minus 1. So, two parameters. One is the text of length n, another one is the pattern of length m. Okay. What is the first step of the KMP? Already you know. The first step is calculation of failure function. So f tends to failure of P. So for the pattern, I calculated the failure function. Now I am taking two parameters, I equal to j, j is equal to 0. I equal to 0, j is equal to 0. Simply I is used to traverse the text, j is used to traverse the pattern. Now while I less than n until the end of the pattern. What is the first step? Compare the first character of the text with the first character of the pattern. If there is a match, move to the next position. If there is a match, move to the next position. If the entire pattern is completed, the particular pattern is available, return the index. Exactly. That is my first step. What is my first step? If T of I is equal to P of J within the while loop, if T of I is equal to P of J, if both are equal, we are checking one condition. If J is equal to m minus 1, what is the meaning? J equal to m minus 1, I said j is used to traverse the pattern if both the characters are equal, and at the same time j is at the last position, means my entire pattern is available in the given text. Yes or no? If this is the condition, then you need to return I minus j. What is I minus j? The answer, that is the index where the pattern is available, then the algorithm is completed successfully. For example, even though there is a match but the end of the pattern is not reached, what happened? Simple procedure. Increment the value of I by 1, increment the value of j by 1 for next element comparison, for next character comparison. Okay, this is the thing. If the characters are matched, obviously what is the another one? Else. Else in the sense, if the characters are not matched, then what you need to do? You need to go through the LPS table. According to the values of LPS table, you need to skip the comparison of the characters. So yes, here we are checking one condition. If j value is greater than 0, whatever the logic we written in failure, here also same logic. J greater than 0, j is updated with a value of f of j minus 1. J is updated with f of j minus 1. Suppose else. For this, if else means j greater than 0 false, that means j value is equal to 0. If j value is equal to 0, simply I is equal to I plus 1. Move to the next character. Okay, this is else case. If case means if there is a match, if the end of the pattern is reached, return the index. If the end is not reached, increment. Suppose if there is no match, use the LPS table. The pattern is updated. Now finally return minus 1. So in the entire table, if all are fail, return minus 1. Return minus 1 in the sense we are coming out of the loop, the entire pattern is checked, there is no match. Okay, now I will implement one example for this KMP algorithm. Suppose consider one text B, I will write down in boxes. B A C B A B A B A B B, A, C. Suppose I will take this text. This is the text, pattern and failure function or LPS table. Write down the indices also. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 15 is the length of the pattern. 15 is the length of the text. Now follow step by step. So what is the first step? Calculation of failure table. Yes, completed successfully. I is equal to 0, j is equal to 0. Parallelly I will write down here. I is equal to 0. Now this is I value and this is j value. Yes or no? Here T of I is equal to P of j. What is T of I? B is equal to A. Condition false. Whenever the condition false, we are moving into else. We are checking j greater than 0. Yes or no? No. J value is equal to 0. If also fail, else I is equal to I plus 1. Now what happened? I value becomes 1. Now I moves to this position. I moves to this position. Again, T of I. T of I means A is equal to J is not updated. A. Both are equal. And is J is equal to M minus 1? No, J value is just 0. Now I is equal to I plus 1. J is equal to J plus 1. Now I value becomes 2. J value becomes 1. This is J. This is I. Now compare the character. C is equal to B? No. C is equal to B? No. Coming to else, check. Is J greater than 0 or not? Yes. J value is greater than 0. If J value is greater than 0 means we are using this table. What we are doing? J is updated with f of j minus 1. Now j is 1, f of j minus 1 means f of 1 minus 1 0. Now j value is equal to 0. Whenever there is a mismatch, use the LPS table. Simple purpose is avoid the backtracking of I. To avoid the backtracking of I, j is moved. J is moved. Okay. Now in the next iteration, is any I is updated? No, I is not updated. Else is this is completed. Again next iteration. In the next iteration, C is equal to A. Condition false. And if j greater than 0 false, directly else. I is incremented by 1. Now this is I value. Next iteration, B equal to A. False. This is also false. Directly I is incremented by 1. This is I value. Right now I value is equal to 4. Yes or no? Right now j is equal to 0. Again compare. A equal to A true. A equal to true. This if false, yes. I is incremented by 1. J is incremented by 1. That is I is equal to 5. J is equal to 1. Compare. B is equal to B. Yes. Again right. I is incremented by 1. J is incremented by 1. Now A is equal to A. Again there is a match. A is equal to A. So I value 7, J value 3. Move. This is J value. This is I value. Next, B is equal to B. Again there is a match. Again there is a match. I is equal to 8. J is equal to 4. Okay. Now A equal to A. Again there is a match. Now I value becomes 9. J value becomes 5. This is J value and this is I value. Now B equal to C. Up to 5 letters are matched. The sixth character mismatch. B equal to C, the condition fail, move to else. In the else, check J greater than 0 or not. Yes, J value is greater than 0. If what happened? Immediately J is equal to f of J value is 5. F of 4. What is f of 4? 3. Now J points to this one. You got it? J points to f of J minus 1. Whenever J only moved means I is not updated. Now what is the value of I? 9 only. J is 3. Again do the comparison. B is equal to B. I think you got the point here. Instead of starting from the first onwards, once the an element involved in the comparison, in the next time the already comparison elements are avoided. That is my concept. B is equal to B. Yes, there is a match. J is incremented. J value becomes 4. I value becomes 10. Now A is equal to A. Yes, A value is equal to A. J is incremented. Now this is J. Now this is I. C is equal to C. Yes. Now I becomes 12. J becomes 6. I becomes 12. J becomes 6. Now A equal to A. A equal to A. I becomes 13. J becomes 7. Yes or no? I becomes 13. J becomes 7. So, see this one. Whenever this happened, actually T of I equal to P of J. Actually, we are not incremented. To be frankly, J is at this position. I is at this position. Yes or no? J is at this position. A is equal to A if J equal to M minus 1. Yes or no? M value is 7. If J is equal to M minus 1, in the sense the end of the pattern is reached. Whenever J reaches end of the pattern means the complete pattern is available in the text. What you need to return? Return I minus J. Return I minus J. That is 12 minus 6. 6 is the answer. Observe, your pattern is available at 6th position. Check this one. What is the 6th position? This one. A, B, A, B, A, C, A. Your complete pattern is available. This is the way to do KMP algorithm for pattern matching. If you are using this LPS table, it simplifies the process of comparison. Thus, we achieve a linear time complexity. Only one loop is there. The time complexity of big O of n is achieved. Okay, this is KMP algorithm. Anyway, if anybody have confusion with the calculation of failure function by using algorithm, go to the another video. In that we discussed the failure function calculation by using a simple procedure of proper prefix and proper suffix. Thank you very much.